Hello everybody. In this video we are going to study separable equations and interval of validity. Separable equations are the differential equations in the form of n of y dy dx equals to m of x. In this equation dy dx is dy prime, and if we multiply the whole equation by dx, we obtain n of y dy equals to m of x dx. So our differential equation is totally separated. Our y variables are on one hand side and our x variables are on one hand side, and it is ready to integrate. Let's see what we mean on the real example. On the example 1, we were given dy dx equals to 8y squared x, and our initial condition, initial value, is given as y of 1 equals to 1/3. So here our first step is to multiply whole equation by dx. So we obtain dy equals to 8y squared x dx. Our second step is to separate x and y variables. So we divide both sides on y squared. So we obtain 1 over y squared dy equals to 8x dx. Now our differential equation is totally separated. Y variables are on one hand side and x variables are on one hand side. Now we can integrate both sides. 1 over y squared is y to the negative 2. So if we use the antiderivative rule, we add 1 to the power and divide it by the power. So here we obtain negative 1 over y equals to, here we obtain 4x squared. And we add c on the x variable side. So this is our implicit solution. Now, given initial value, we're going to find c. So we're going to plug in 1 as our x and 1/3 as our y. So negative 1 over 1/3 equals to 4 times 1 squared plus c. This part will be negative 3, and this part will be 4 plus c. Here c will be solved as negative 7 if you subtract 4 on both sides. Now we can plug c value. So 1 over negative y equals to 4x squared minus 7. Here, if we solve for y, we obtain the explicit solution. So if we multiply by negative sign and invert the fraction, then we find y equals to 1 over 7 minus 4x squared. So this is our explicit solution. Now we are going to check interval of validity. Interval of validity is the range of independent variable. Here our independent variable is x. So we are going to check the range of the x we can plug in. So when we are finding the interval of validity, we are going to avoid division by 0, obtaining complex numbers, logarithms of negative numbers or 0, and negative value under the square root sign. So here we have denominator, and we would like to find what makes this denominator 0, so we can avoid division by 0. So 7 minus 4x squared equals to 0. We set it equal to 0 and solve for x. So we subtract 7 on both sides. We multiply by negative sign. We divide by 4. And we take the square root. And when you're taking square root, it goes out as plus and minus sign. So we have 2 points that makes this denominator 0. So we're going to exclude those 2 points on the range of the independent variable. So negative square root of 7/4 and positive 7/4 under the radical sign will be our asymptotes. Actually, our graph will be something like this. So our interval of validity is the range of independent variables. So we're going to check the given initial value, x value. So our given initial x value is 1. So our interval where the x value is 1. So it falls into this zone. So our interval of validity is between 7/4 negative and positive. And our whole interval is negative infinity up to negative radical 7/4 is the first zone. Union this our interval negative 7/4 comma positive 7/4 under the radical sign. Union 7/4 under the radical sign comma positive infinity. So when we are finding the interval of validity, we check the initial independent variable value. Here in this case it is x and it is 1. So 1 falls into this zone. Let's go to example 2. Example 2. In this example, we have y prime equals to 12x squared plus 4x minus 3 all over 2y minus 3. And our initial condition is given y of 1 equals to 1. Our first step is to convert y prime into dy dx. So dy dx will be equal to 12x squared plus 4x minus 3 all over 2y minus 3. Our next step is to cross multiply. So we're going to multiply dy times this denominator and dx times this numerator. So we have 2y minus 3 dy equals to 12x squared plus 4x minus 3 dx. As we can see, our x variables are here on one hand side and our y variables are here on other side. So this is totally separated. Now we can integrate both sides. So 2y integrated with respect to y is 2y squared divided by 2 minus 3y. Antiderivative of the constant with respect to y is constant times y. And antiderivative of 12x squared is 12x to the third divided by 3. We add 1 to the power and divide by the power. Plus 4x squared divided by 2 minus 3x plus c. We put c on the x side. So if we clean up, this is going to be our implicit solution. So y squared minus 3y equals to 4x to the third plus 2x squared minus 3x plus c. This is our implicit solution. So using given initial value, we're going to solve for c. Our given initial value was y of 1 equals to 1. So here our x value is 1 and our y value is 1. Now we're going to plug in. So 1 squared minus 3 times 1 equals to 4 times 1 cubed plus 2 times 1 squared minus 3 times 1 plus c. This is going to be 1 minus 3 will be negative 2. 1 cubed is 1 times 4 is 4 plus 2 minus 3 plus c. So this is going to be positive 6, and if we subtract 3 on both sides, c will be equal to negative 5. Now we can plug in -5 on the c. So y squared minus 3y equals to 4x to the third plus 2x squared minus 3x minus 5. Now we're going to work on this equation, and we're going to solve for y to be able to find the explicit solution. And then we're going to work on the interval of validity. Now we realize that this is a quadratic equation, and we're going to put this quadratic equation into standard form. Standard form of the quadratic equation is ax squared plus bx plus c equals to 0. So here our variable is y. So y squared minus 3y, and we subtract this whole constant on both sides. So negative 4x cubed plus 2x squared minus 3x minus 5 equals to 0. Now this is our standard form. This is our a term, this is our b term, and this is our c term. So our a term is 1, our b term is -3, and our c term is negative 4x cubed plus 2x squared minus 3x minus 5. Now we're going to apply the quadratic formula to be able to solve for y. Our quadratic formula was -b plus or minus square root of b squared minus 4ac, which is the discriminant, divided by 2 times a. Now we're going to place a, b, and c values into our quadratic formula. So this is going to be our explicit solution. So y is equal to -b is -3. Our b value is -3, plus or minus square root of b squared, which is -3 squared, minus 4 times a times c. A is 1, and c is negative 4x to the third plus 2x squared minus 3x minus 5, divided by 2 times a, 2 times 1. So we're going to clean up this equation. So y is equal to 3 plus or minus, so -3 squared is 9. So we have -4 times -4x cubed is positive 16x to the third. -4 times, this is going to be negative, and negative times negative is positive, positive 8x squared. -4 times -3x times negative will be negative 4 times 3 is 12, -12x. And -4 times -5 is 20, and we have another negative sign here, so it's going to be -20 divided by 2. And here we can merge the like terms, 9 and 20, so it's going to be -11. So our final equation will be 3 plus or minus square root of 16x to the third plus 8x squared minus 12x minus 11 divided by 2 is our explicit solution. Now we are going to check interval of validity. Here we have two concerns. One concern is the negative value under the radical sign, and another thing is whether to accept plus or negative version. So we're going to use the initial condition given. We have y of 1 equals to 1. And under the radical we have 16x to the third plus 8x squared minus 12x minus 11 has to be greater than or equal to 0. So if we plug in our x value, this is our x value and this is our y value. So we're going to obtain 16 times 1 cubed plus 8 times 1 squared minus 12 times 1 minus 11 will be equal to 1. So now we don't have to worry about under the radical because it is greater than or equal to 0. Now we would like to know which value we are going to accept, plus or negative sign. This time we're going to plug in our y value and check the both sides of the equation. So our y value is also 1. So 1 is equal to 3 plus or minus. We found under the radical 1 and divided by 2. So 1 is equal to which value of the numerator will give us 1 here. So if we accept plus sign, square root of 1 is 1. So we have 1 here. 3 plus 1 divided by 2 or 3 minus 1 divided by 2. So it's going to be 3 minus 1 divided by 2. Then we can obtain 1 is equal to 1. So we're going to accept the negative part here. So now we know the interval of validity. Let's check example 3. Here we were given dy over dx equals to e to the x minus y. So here we're going to use the rules of power, exponential rules. So we're going to separate this. So our first step is to rearrange the right hand side. Dy over dx will be equal to e to the x times e to the negative y. Because we know that a to the b times a to the c is equal to a to the b plus c using the exponential rules. And we can rearrange e to the negative y as 1 over e to the y, and we can rewrite the whole equation as dy over dx equals to e to the x over e to the y. Now our second step is to cross multiply. So we're going to cross multiply. So e to the y dy equals to e to the x dx. Our differential equation is totally separated. Our x term is on one hand side, our y term is on one hand side. Now we can integrate both sides of the equation. Antiderivative of e to the y is e to the y. And antiderivative of e to the x is e to the x. And we add c on the x variable side. This is our implicit solution. Now we're going to find the explicit solution by solving for y. Now we can ln on both sides. So ln of e to the y is equal to ln of e to the x plus c. Let's recall ln of e to the x is equal to x. So here ln of e to the y is equal to y. So this is our explicit solution. Here we are not going to check the interval of validity because we were not given any initial condition. If we had initial condition, we could check interval of validity using x and y values here. So let's go to example 4. Example 4. dy over dx is equal to 1 over secant squared of y. Here we see that y variable is here, so we can directly cross multiply. So secant squared of y dy equals to 1 dx. Here we see that y is on the dy side, so we can start integrating. Antiderivative of secant squared is tangent. So we have tangent of y equals to antiderivative of 1 with respect to x is x plus c. So this is our implicit solution. For explicit solution, we have to solve for y. We are now going to inverse tangent on both sides. So arctangent or tangent inverse, which is the same thing, that we're going to apply on both sides. So arctangent of tangent of y will free our variable y, and right hand side will be arctangent of x plus c. So arctangent of x plus c is our explicit solution. Now example 5. dy over dx equals to x e to the y. Our first step is to multiply both sides on dx. So we're going to obtain dy equals to x e to the y dx. Now we're going to divide both sides on e to the y. So 1 over e to the y dy equals to x dx. Now we have x variables on one hand side and y variable on one hand side. So now we can integrate. This is e to the negative y. Antiderivative of e to the negative y is negative e to the negative y. And antiderivative of x is 1/2 x squared. Plus c, we put c on the x variable side. So this is our implicit solution. Now we're going to find the explicit solution by solving for y. So our first step is to multiply both sides by negative. So we obtain e to the negative y equals to negative 1/2 x squared minus c. Now we're going to ln on both sides. Let's remember ln of e to the x is equal to x. So ln of e to the negative y will be equal to negative y. So ln of negative 1/2 x squared minus c, and now we multiply both sides on negative again, so y is equal to negative ln of negative 1/2 x squared, and we write plus c because c is the constant and we express as plus c. Now this is our explicit solution. Our next problem is dy over dx equals to 2x over e to the 2y. Our first step is here. After we observe, we see that we need to cross multiply. So e to the 2y times dy equals to 2x dx. Now we can integrate. So antiderivative of e to the 2y is 1/2 e to the 2y, and antiderivative of 2x is 2x squared divided by 2 plus c. Now we're going to simplify this, and this is our implicit solution. Now we can find explicit solution by solving for y in this implicit solution equation. So step 1, we multiply both sides by 2. So e to the 2y equals to 2x squared plus c. Now we're going to ln on both sides. So we know that ln of e to the x equals to x. So ln of e to the 2y is equal to 2y. So 2y equals to ln of 2x squared plus c. And we divide both sides on 2, so we obtain y equals to ln of 2x squared plus c divided by 2. This is our explicit solution. Problem number 7. We have y prime equals to 2xy cubed over square root of 1 plus x squared. And our initial condition is y of 0 equals to 1. Here our first step is to convert y prime into dy dx. Our next step is to cross multiply. So we obtain square root of 1 plus x squared dy equals to 2xy cubed dx. We would like x terms on one hand side and y terms on one hand side. So we divide both sides of the equation by 1 plus x squared and simultaneously by the y cubed. So we carry x's on right and the y's on the left hand side. So here we obtain 1 over y cubed, which is y to the negative third dy, equals to 2x over square root of 1 plus x squared dx. This cancels this cancels that. Now the equation is totally separated. We can start integrating. So the left hand side will be y to the negative third plus 1 over negative 3 plus 1, which is going to be negative 1 over 2y squared, equals the right hand side. We're going to use substitution. So let u be equal to 1 plus x squared. Then the u will be the derivative of this, which is 2x dx. And if you solve for dx here, dx will be du over 2x. Now let's place everything in terms of u. We have integral 2x over square root of u, and instead of the x we have du over 2x. 2x cancels, so we have integral 1 over square root of u du. Now we know how to integrate this. We can express square root of u as u to the 1/2, and if we take it to the numerator, it's going to be u to the negative 1/2. And we add 1 and divide it by the power. So on top we have u to the 1/2, and on the bottom we have 1/2. So it's going to be 2u square root plus c. So we obtain 2 square root of u plus c. So this is our implicit solution. Now we are going to use the initial condition to solve for c. We are given y of 0 equals to 1. Here 1 is the y variable, 0 is the x variable. So negative 1 over 2 times 1 squared equals to 2 times. We have to bring u back here, which is square root of 1 plus x squared. So 1 plus 0 squared plus c. Left hand side is negative 1/2. On the right we have 2 times square root of 1, which is 1, so 2 plus c. So here if we solve for c, c is equal to negative 1/2 minus 2, which is negative 5 over 2. So this is our c value that we can plug in. So negative 1 over 2y squared is equal to 2 times square root of 1 plus x squared minus 5 over 2. Here we are going to solve for y to find for explicit solution. So here our first step is to multiply whole equation by -2. So we have 1 over y squared equals to -4 times 1 plus x squared plus 5. Our next step is to invert the fractions. So y squared will be equal to 1 over, and we can express this as 5 minus 4 times square root of 1 plus x squared. Now we are going to take the square root on both sides. So y is equal to plus or minus square root of 1 over 5 minus 4 times square root of 1 plus x squared. This is our explicit solution. Now we're going to check the interval of validity. Here we have two concerns. One, under the radical we cannot have negative value. Second, we're going to pick up either plus or negative sign here. Here, our square root sign here has no problem because 1 plus x squared is always positive because of the even power here. Now we're going to apply the initial condition and check whether we're going to accept the plus or negative sign for the solution. Our initial condition was y of 0 equals to 1. Here our x value is 0, our y value is 1. So if we plug in, 1 is equal to plus or minus square root of 1 over 5 minus 4 times 1 plus 0 squared. So here we obtain 1 is equal to plus or minus. So this is 1. Square root of 1 is 1. 4 times 1 is 4. 5 minus 4 is 1. 1 divided by 1 is 1. And square root of 1 is 1. So we need to accept the plus sign because we have positive 1 on the left. So our solution is the plus. Example 8. Again, our first step is to convert y prime into dy dx. And then we're going to multiply by dx and divide by e to the negative y simultaneously. So we obtain e to the y dy equals to 4x minus 8 dx. Now we can integrate on both sides. So antiderivative of e to the y is e to the y, and antiderivative of 4x is 4x squared divided by 2. Antiderivative of 8 is 8x plus c. If we simplify, we obtain e to the y is equal to 2x squared minus 8x plus c. This is our implicit solution. Now we're going to find value of c and then work on the explicit solution. Our initial condition was y of 1 equal to 0. 1 is x, 0 is y. So e to the 0 is 1, and this is going to be 2 minus 8 plus c. This is negative 6. Then c value will be 7. Now we can rewrite e to the y equals to 2x squared minus 8x plus 7. Now we're going to work on this equation and solve for y. So we can ln on both sides. So ln here, ln here. So we know that ln of e to the x is equal to x. So ln of e to the y is equal to y. So ln of 2x squared minus 8x plus 7. This is our explicit solution. Let's check interval of validity. So the argument of ln cannot be negative. So we're going to check 2x squared minus 8x plus 7 is greater than 0 value. This is a quadratic equation, so we can use quadratic formula. So x will be equal to negative b plus or minus square root of b squared minus 4ac all over 2 times a. Here in our case, 2 is the a term, negative 8 is the b term, and 7 is the c term. So negative b is positive 8 plus or minus b squared is 64 minus 4 times a is 2 and c is 7 divided by 2 times 2, 4. Here 4 times 2 is 8, 8 times 7 is 56, and 64 minus 56 is 8. So we have 8 here. Square root of 8. So we have x is equal to 8 plus or minus square root of 8 divided by 4. We can simplify this. 8 divided by 4 is 2. So x is equal to 2 plus or minus square root of 8. Now let's find this value using the calculator. Or you can leave it like that, and when you're graphing, you can apply this. So this point here will be 2 minus square root of 8, and this point on the right will be 2 plus square root of 8, and the valid zone will be in between. So this is our valid zone here, and here, here and on. Let's see example 9. Here our first step is to cross multiply. So theta dr is equal to r squared d theta. Now we would like theta on right hand side and r on the left hand side. So we divide by r squared and theta simultaneously. So r to the negative 2 dr is equal to theta to the negative 1 d theta. Now we can integrate both sides. So integral of r to the negative 2 is negative 1 over r, and integral of theta to the negative 1 is ln of theta plus c. So this is our implicit solution. Now we're going to apply the initial condition and solve for c. Our initial condition was r of 1 is equal to 3. Here, this is our theta, this is our r. So negative 1 over 3 is equal to ln of 1 plus c. We know that ln of 1 is equal to 0. and c is equal to negative 1/3. So we can plug in negative 1 over r is equal to ln of theta minus 1/3. Here we're going to solve for r. So our first step is to multiply by negative sign. So 1 over r is equal to 1/3 minus ln theta. Then next step is to invert the fractions. Then r is equal to 1 over 1/3 minus ln theta. This is our explicit solution. Let's check interval of validity. We know that theta cannot be equal to 0 because this is natural log. And we don't have to worry about negative value of theta because absolute value takes care of the negative sign here. Also, division by 0 is our problem because 1/3 minus ln theta is at the denominator. So we're going to do this. We're going to set 1/3 minus ln theta equal to 0 and solve for theta here. So here, next step is ln theta is equal to 1/3. And if you raise to the e power, we know that e to the ln of x is equal to x. So e to the ln of theta is equal to theta here. So absolute value of theta is equal to e to the 1/3. And if we get rid of the absolute value sign, then theta will be equal to plus or minus e to 1/3, which is theta is equal to plus or minus cubic root of e. So this is the value critical point. So our interval is negative infinity up to negative cubic root of e union negative cubic root of e up to 0 because we can't have 0 as theta, union 0 comma cubic root of e union cubic root of e up to infinity. Our given initial condition was r of 1 is equal to 3. So our theta value is 1. So we're going to find where 1 falls in these zones. We have 4 zones: zone 1, zone 2, zone 3, zone 4. So our actual zone is here because 1 falls into this zone.